So let's talk how the Hope's apparatus works. So the given picture is of Hope's apparatus. So Hope actually. Hope was a chemist, and he invented this. He invented this apparatus to check the anomalous behavior of water, which is more appropriate word for that. So he used it for checking the anomalous anomalous that is behavior of water, that is H2O. That O is so so he used that to check the anomalous behavior of water. So in the other video, that is why do fish survive, I had told you about the anomalous behavior of water. So now let's see how he did that. So basically, let's first check the construction of it. So we have here two thermometers. So this is thermometer 1 T1 and thermometer 2 T2. Don't check the temperature right now, we will check it afterwards, explain you about it afterwards. So this is a cylinder, so it's not labeled, so I will label it. So this is the cylinder. It's mostly metallic cylinder. So let's write it only because it's mostly a metallic cylinder. Then this is a beaker, or you can place any vessel to collect the water. So this is the outlet. This is also not shown in the diagram. So this is the outlet. Then this is the vessel for collecting the water. So vessel, this is the vessel. So metallic cylinder, vessel. And then we have the freezing mixture. So now what do you mean by freezing mixture? Is there any special mixture? So no, it's not the freezing mixture. That is freezing mixture is equal to, that is nothing but ice ice plus salt. So it's nothing but ice plus salt. So this is ice plus salt. So this is the freezing mixture. So this is ice plus salt. So salt, why salt is used? Then salt you can see in snow worlds and something like related to snow, some salt or a large amount of salt is used. So salt slows down the tendency of ice to melt. So it's the freezing mixture is used, which is ice and salt. Just simple that. And then this is a bowl like structure. So this is also not labeled. So this is the bowl like structure in which the freezing mixture is poured. So this is the bowl. This is the bowl in which the freezing mixture is. So now we have done with, yes, and some water is poured of more than 4 degrees Celsius temperature, because the anomalous behavior of water is between 0 to 4 degrees Celsius. So let's write that also. So for H2O between between 0 to 4 degrees Celsius. So 0 degrees Celsius to 4 degrees Celsius. So water, so this is the water. We'll write H2O. So water with temperature more than 4 degrees. So H2O with temperature more than, oops, more than 4 degrees Celsius. So more than 4 degrees Celsius. So that is we can say the tap water is poured in it. So now let's see how it works. So at first, as the freezing mixture is cool, that is its temperature can be that is 0 or less than 0. So this temperature less than 0, so it absorbs the heat of water from the cylinder, so it absorbs the heat of the water from the cylinder, and the temperature of the water near this bowl decreases. So the temperature of the bowl near this water decreases. Hence, as the temperature decreases, its volume decreases and density increases. So as temperature decreases, it's that is the as temperature becomes low, the volume also becomes the volume increases and oops, no, not volume, I made a mistake. So volume decreases and density increases. I told you vice versa. So volume decreases and density increases. So the as dense of and density of this water is high. So let's color it black. So the density of this water is high. This part, the water in this part is high. So it moves downwards. So it moves downwards, and then hence the temperature from the thermometer also decreases. The temperature from the thermometer decreases, and this continues. The temperature, there is a rapid fall in temperature, and this continues till the water becomes equal to 4 degrees Celsius. So it's given here 4 degrees Celsius. So it continues till water becomes 4 degrees Celsius, till H2O becomes 4 degrees Celsius. Now after 4 degrees Celsius, we see the anomalous behavior of water. So after 4 degrees Celsius, its volume instead of contracting more, it expands. That is the anomalous behavior of H2O. It expands, and its density decreases, so it moves upward again. So it moves upward again, and then there is a rapid fall that when the thermometer so 2, which continues till 0 degrees Celsius. So till in thermometer 1, I'll specify more, and in thermometer 2 till H2O becomes 0 degrees Celsius in T2, that is thermometer 2. So in this way we have checked the anomalous behavior of water using the Hope's apparatus. We found out that the after 4 degrees or below 4 degrees Celsius, the density of water decreases instead of increasing. And finally, when the whole mixture this stops, or slowly and slowly the temperature in thermometer 1 also goes to 0 degrees Celsius. That is the whole mixture, the water in the cylinder becomes 0 degrees Celsius finally, according to the principle of heat exchange. And this is used as some ice or some freezing mixture melts, as it absorbs heat from the water, and hence that water is collected here, that can be used again or may not be used again. So it's not much that much difficult. Thank you.